I wanted to give you a brief look at the history of the Syn-Limb, how we developed it and where it's going, because development is ongoing. So the very first prototype I actually built myself on a piece of strap PCB where you have these copper lines on the back, and I drew up the diagram for this with the help of Krisi of Koma Electronic. And this had a single channel only, and as you can see, it was a very crude device, but it actually worked with a single channel, but it worked. The next iteration was that Krisi designed a proper circuit board and had it printed by the manufacturers he uses in China for the synthesizers and modules that he builds. And that's what's sitting in the current prototype of the Syn-Limb, which is this, inside here of this 3D printed case. And again, to explain how this works, you have two channels, here with these two CV output jacks. And for each of the channels, you have these two potentiometers. One of them sets the strength of the amplification of the muscle signal, and the other sets kind of a baseline of where the signal starts, whether it starts really low or a bit further up, which can be sometimes useful for filter operation, for example. However, this device is still relatively crude, and we realized it has two massive shortcomings. First, it's really sensitive to grounding issues. So whenever I touch something that is made of metal and has a little bit of an electrical current inside, that carries across my skin into the Syn-Limb and produces weird results, especially if there is a difference in voltage between what's coming from the synth and from my body. So sometimes it will pick up signals that aren't really there. So that's a big issue. And in all honesty, there's also a bit of a safety issue here. Because basically I am attaching my body with these electrodes in my prosthesis to a synthesizer via cables. And the synthesizer has a power brick attached to it. And if, God forbid, anything should happen, like a short circuit, it is at least theoretically possible that the electricity travels through the Syn-Limb into my body. And of course, we can't really have that, especially not if we want to share the design with other people who might potentially use it. That is why we have just come up with the Syn-Limb 2.0, the next iteration, which looks like this. It doesn't have a case yet. As you can see, it looks much bigger. That's because it has these two satellite PCBs that here are still attached, but those are going to be cut off. And they will have these LED blocks on them, like lights on like an old amplifier, to give a better visual feedback of the signals that I'm producing. Most importantly, however, there is now a circuit in place that provides complete electrical separation between the synthesizer, which is here on the front side of the device, and the prosthetic side, which is here on the back side of the device, which is achieved with these two very specific chips that convert an electrical signal into a wireless signal and then back into an electrical signal. So an electrical signal comes in, is then turned into a wireless signal, and then the electrical signal comes out again. And in this way, you get an electrical uncoupling between two circuits that can still transmit information to each other. And in this way, electricity from the synthesizer cannot travel into my prosthesis, which makes the device much safer. These security devices are typically on, and for those, you need to put these switches up. And then there's also an additional new switch here, which inverts the output, so that even if I'm not sending an electrode signal, I will have a high out, and when I'm sending an electrode signal with my prosthesis, that will go low. So that, for example, would allow me to kill a kick drum for a second or so, applications like that. So the ultimate goal is to add Bluetooth to this so that I could wisely control wireless musical devices, anything that works with MIDI over Bluetooth, potentially even remote control some stuff on the computer. So that's still room for future improvement, but I hope you can see that the development of the Syn-Limb is ongoing. And once this is ready, we hope to share it with the public in form of an open source project.